Hi, I'm Dr. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the topic sampling distribution. Before going to discuss about sampling distribution, we have to learn some basic concepts regarding sampling distribution. The first basic concept is population. What is mean by population? What is mean by population? The collection of objects or group of objects or set of objects is known as population. The collection of objects or set of objects or group of objects is known as population. It may be finite population or infinite population. What is mean by finite and infinite population? If I take one example, the students in a classroom may be treated as finite population because we can count the number. That's why such a type of population is known as finite population. Suppose if I take another example, the goods prepared in a factory may be treated as infinite population because every day we are going to prepare the goods in a particular factory. We cannot count. Such type of populations are known as infinite populations. Generally, the population size is denoted by capital N. Suppose the students in a classroom are 60 members. So we can denote it with capital N equal to 60 because the population size is capital N. So finally, we can conclude that what is mean by population? The collection or group or set of some objects is known as population. Then the second definition, what is sample? Sample means, see, we have discussed the population, the part of the population or subset of the population. The part or subset of population is called sample. The sample size is denoted by small n. The sample size is denoted by small n. Suppose in a classroom there are 60 members. If I consider this is a population, I want to choose a sample from that particular classroom with 5 students. So small n, the sample size is 5 members. See, this 5 is less than 60 members. This is a part of the population or subset of the population. That's why this is known as sample. Here, the sample divided into 2 parts. One is small sample and one is large sample. Based on the size of the sample. See, the sample size is denoted by small n. If this size is less than 30, number less than 30, such type of samples are known as small sample. If the sample size is greater than or equal to 30, then such type of samples are known as large samples. Now, we are going to discuss what is sampling. As of now, we discussed population and sample. And next topic, sampling. These two we got clear idea and we are going to discuss what is mean by sampling. As of now, we know population means the group of objects. Sample means subset of population. What is the meaning of sampling? See, the process of choosing samples. The process of choosing samples from a population is called sampling. The process of choosing samples from the population is called sampling. Suppose, I'll take with one example. Population size, the class strength is 60 members. And I want to choose one sample with the size 5. How to choose These 5 members are 5 students from 60 students. I will give one condition that how to choose these 5 members from 60 members. I need 2 girls and 3 boys. That is one condition, or that is one process, or that is one way. The way of choosing or the process of choosing samples from the population is called as sampling. Suppose if I give one more way, I need 5 boys. That is another way. I want 4 girls and 1 boys. That is another way. Like that, the process or way of choosing the samples from the population is called sampling. Now, we are going to discuss parameters and statistics. What is the meaning of parameters and statistics? See, suppose if I consider population and sample. Population size is denoted by capital N and sample size is small n. I consider the populations. First population x1, x2, third population, so on, xn. Similarly, samples I am going to take with small x1, x2, x3 and so on, xn. These are the capital X1 to capital Xn are populations and small x1 to small xn are samples. Now we are going to discuss 3 topics on population and sample, which are mean, variance and standard deviation. We are going to discuss mean, variance and standard deviation for population side, similarly for sample side. For population side we can call as parameters and for samples we can call as statistics. The mean, variance and SD of population we can call as parameters. Similarly, the same concepts mean, variance and SD of sample we can call as statistics. That is the difference between parameters and statistics. We are going to discuss what is mean, what is variance and what is SD of population, which are known as parameters. Similarly, what is mean, variance, SD of sample, which are known as statistics. And to find this mean of population, the symbol is mu. Mean of population symbol is mu. And these we know that populations, different populations. Mean means average. The sum we can add x1 plus x2 plus x3 plus xn by capital N. We can symbolically written as 1 by n into sigma I equal to 1 xi. Now coming to the mean of sample, here we have a small x1 to small xn. The average of this one is 1 by small n sigma xi. This is called mean of the population and this is called mean of the statistic. Sorry, the mean of the sample. Coming to variance, the symbol is sigma square. To find this variance, first we have to find out what is mu, mean. After getting mean only, we can find out variance by using this formula 1 by n sigma xi minus mu whole square, where xi is this one x1 minus mu whole square plus x2 minus mu whole square plus x3 minus mu whole square and so on xn minus mu whole square by n, which is sigma square. That is called variance of the population. Now coming to variance of the sample, this symbol is s square. To get this variance of the sample, first we have to find out mean of the sample, which is x bar. After getting x bar, 1 by n minus 1, not n, 1 by n minus 1 sigma xi minus x bar whole square, where xi is statistics, x1, x2, x3 and so on. x1 minus x bar whole square, sigma is there, that's why plus x2 minus x bar whole square plus x3 minus x bar whole square and so on by n minus 1. This is variance. Now, SD or standard deviation of the population, which is sigma under root of sigma square, under root of variance. Here also the standard deviation of the sample, which is S under root of S square, that is 1 by n minus 1 xi minus x bar whole square under root. So, finally, we concluded that mean, variance and standard deviation, these three we can call as parameters of population. Mean, variance and SD of sample we can call as statistics. Here the symbols are very, very important. Again, I am going to repeat: population, sample, mean is mu, population mean, sample mean is x bar. Now, variance is sigma square, the sample variance is s square. Now, standard deviation is sigma and standard deviation of sample is s. Total is 6 values: mean, variance, standard deviation of the population, mean, variance, standard deviation of the sample. These three are called parameters and these three are called statistics. So, these are parameters and statistics related to population and sample. Now, we are going to discuss sampling distribution. As of now, we discussed population, sample. Now we are going to discuss sampling distribution. Totally 3 parts. We have completed this one and we have completed this one. What is mean by population? The collection of objects, the subset of population. The mean is mu, sigma square, sigma. Here x bar, mean of the sample, variance of the sample, s square, SD of the sample, s. Similarly, we are going to discuss what is sampling distribution and what are mean, variance and standard deviation of the sampling distribution. First, we have to go to discuss about sampling distribution. What is sampling distribution? See, the set of all possible samples or the group of all possible samples is called sampling distribution. The set of all possible samples from the population is called sampling distribution. Simply, I will explain you. Suppose the classroom strength is 60 members and sample strength is 5. I want to choose one sample with the size 5. That means out of 60 students in the classroom, I want to choose only 5 students. That is one sample, x1. After taking these 5 students, I want to choose another 5 students. That is second sample, x2. I want to choose another sample, x3. From 60 members only. From 60 members only. Like that, we can choose some samples, all possible samples from the total strength of the population is 60 members. So, here I choose an x1, x2, x3 and so on xn. The set of, the bracket means the group of or the set of all possible samples is called sampling distribution. So, the set of all possible samples from the population is called sampling distributions. Now, here one important note is there, note 1 and note 2 regarding how many samples we can choose. How many samples we can choose. Here we have 2 ways to choose the samples. Suppose the total strength is 60. I want to choose 5 students. One sample. See, here we have 2 possible cases. One is with replacement case and second one is without replacement case. What is the meaning of with replacement and without replacement case? I'll explain you. Out of 60 students in the classroom, I want to choose 5 students. First of all, I'll choose 5 students from the class. These 5 students may be the combination of boys and girls. In case if I assume 3 girls and 2 boys, one sample is over, x1. Now, before going to choose another sample, this first sample I merged in the population. That means I replaced in the population. Then I am going to choose another sample. That is called x2. Before going to choose another sample, third sample, the second sample also I replaced in the population. That means whenever we are choosing the samples, the previous samples we are replacing in the population. Such case is known as with replacement because we are replacing. In that case, with replacement case, how many samples we can draw? That means total capital N power N samples can be drawn. Suppose capital N equal to 60 and small n equal to 5. We can draw 60 power 5 samples in with replacement case. Because while we are choosing the samples, the previous samples we are replacing in the population. That's why it is never-ending population, not finite population, which is infinite population. That's why with replacement is also known as sampling from infinite population. In infinite population or with replacement case, we can draw capital N power N samples. Suppose in sampling without replacement, same case if you take, I want to choose 5 students from the sample 60 population. I chosen 5 students, that is x1. And before going to choose the second sample, I am not going to replace the first sample into the population. That means this case is known as without replacement. After choosing the second sample, next I am going to choose the third sample. While choosing the third sample, the first 2 samples we are not going to replace in the population. That means that case is without replacement case. In this case, we can draw NCN samples. That means 60C5 samples. So without replacement, NCN samples we can draw, and with the replacement, capital N power N samples we can draw. And in without replacement, we can call as sampling from finite population. Because in without replacement, the way we are choosing the samples, at the end, all the population students will be 0. That's why it may be finite population, not infinite. But in without replacement case, in with replacement case, it is called infinite population because the population never ended. And without replacement, which is known as finite population because the population will be ended. Because we are not replacing. So, finally, we have to remember in sampling distribution, NCN or N power N. This is with replacement case. This is without replacement case. With replacement, we can call as infinite population, and without replacement, we can call as finite population. A small difference is there with replacement. With replacement, we should remember that never ending, and without replacement, it will be ended. So that's why never ended means infinite population, will be end means finite population. Like that we should remember. So this is the sampling distribution concept. The set of all possible samples is called as sampling distribution. Now we are going to discuss this sampling distribution, mean, variance and SD. For this also, the symbols, mean of the sampling distribution, mu x bar. Variance of the sampling distribution, sigma square x bar. And SD of the sampling distribution, sigma x bar. What are the formulas for this? We are going to discuss in the next slide. But these 3 also we are going to discuss, mean, variance and SD of the sampling distribution. In the previous slides, we discussed mean, variance, SD of the population and sample. Now we are going to discuss mean, variance, SD of the sampling distribution. We have clear idea about sampling distribution. Sampling distribution means the set of all possible samples is called sampling distribution. Like this, we should remember. Sampling distribution is all possible samples. In with replacement, n power n samples we can draw, and without replacement, we can draw NCN samples. Now, this sampling distribution, we are going to discuss mean, variance and SD. Here with replacement case. With replacement, how many samples we can choose? Capital N power n. Remember. Actually, the sampling distribution is the set of all possible samples. Here, the formula mu x bar, xi bar. First, we have to find out mean of all the samples. That is x1 bar, x2 bar, x3 bar, and so on, xn bar. After getting all the samples, first we have to find out the mean of all the samples. The average of this means mean of sampling distribution. The mu x bar 1 by capital N power n, because it is with replacement. In case if it is without replacement, we can take here 1 by NCN, sigma xi bar. And variance is 1 by n power n sigma xi bar minus mu x bar. To get this variance of sampling distribution, we require mean of the sampling distribution mu x bar. SD is under root of. So we discussed here mu x bar, sigma square x bar and sigma x bar. These three are mean, variance, SD of the sampling distribution with replacement. And in without replacement, only this will be changed. In without replacements, everything is same, sigma xi bar minus mu x bar and this one. But only the change is 1 by NCN. In with replacement, we take an n power n, but without replacement, we can choose how many samples? NCN samples. That's why 1 by NCN. Here also we discussed mu x bar, sigma square x bar and sigma x bar. In without replacement case, the previous slide with replacement case. Now, finally, we discussed three concepts: population, sample and a sampling distribution. Population mean mu, sample mean x bar and sampling distribution mean mu x bar. Population variance sigma square, sample variance s square and sampling distribution variance sigma square x bar. The SD of the population sigma, the SD of the samples S and SD of the sampling distribution is sigma x bar. Total 9 values. Mean, variance, SD of population, mean, variance, SD of sample and mean, variance, SD of the sampling distribution. Total we have 9 values. All are mean, variance and standard deviation. In population case, in sample case, similarly in sampling distribution case. In case if you compare these values, this mu, population mean and sampling distribution mean always same. That point we discussed. Mu x bar is always equal to mu. That means mean of the population, similarly mean of the sampling distribution are same. That is the first point. But variance of the population not equal to variance of the sampling distribution. See, this is variance of the sampling distribution, this is variance of the population. Both are not same. Like mean of the population and mean of the sampling distribution. But the variance of the standard sampling distribution, which is not equal to sigma square, but which is equal to sigma square by n. If the population is infinite. Infinite means with replacement case. In finite case, that means without replacement case. Without replacement means NCN, with replacement means N power N. Sigma square x bar not equal to sigma square, but sigma square by small n, capital N minus small n by capital N minus 1. These conditions are satisfied in the variance cases. Here, the extra term, this one is there, na, capital N minus small n by n minus 1, which is called as correction factor. And this sigma by root n, sigma square x bar equal to sigma square by n. If you take under root, this is sigma by root n. That is called standard error. Standard error. Now we concluded that finally with all the 9 values, the mean of the population and mean of the sampling distribution both are same always. And in variance case, both are not same. Variance of the population and variance of the sampling distribution both are not same. But the variance of the sampling distribution is equal to variance of the population by n in infinite population case. For finite population case, sigma square by n into capital N minus n by capital N minus 1. For finite population or without replacement case. So this extra part we can call as correction factor, and sigma by root n we can call as standard error. Now, so this is the difference between population, mean and sampling distribution. In the next session, we are going to discuss the problems and sampling distribution. What are the problems? Very simple. We are going to calculate these 3: mean, variance, SD of the population. Similarly, mean, variance and SD of the sampling distribution. According to the problem, either it may be with replacement case or without replacement case. We can calculate all these 6 values: mean, variance, SD of the population. Similarly, mean, variance and SD of the sampling distribution. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.